Okay, let's go ahead and get started. So we'll talk about, today we're going to start jumping into the second half of this course. So we're doing great moving on with file systems. File systems are actually incredibly important. And today we're just going to talk about the file system interface, which is basically talking about the capabilities we want when we work with files, which happens to mean more than just opening and reading and writing to them.
Lies.
Really? What else do you think we'd need with a file, Matt?
Well, you might want like some indexy stuff to find it faster or something.
Okay.
But besides that,
What about security?
Such a strong term here. All we need is space for the file to read, write to it. That's it.
What about security? What if this is the military?
It's not a need.
The military doesn't need security? We don't need to protect our sensitive data?
That's a want from the military. And so the programmer needs to add it in. But it's just a want.
It's just a want? So the military doesn't need it in order to protect the U.S.?
No,
What
they
about
don't-
if you have...
They don't need it.
they might want it really bad.
They will still survive without it. Therefore, they
Will they? I mean, what if all of our enemies got hold of this and they're able to build it faster and quicker?
They don't need to protect the file. They need to protect their system.
And maybe you could do that through your file system.
That's
But they
going a
need
level
security.
deeper. They don't need that. If the computer's protected, the files are protected.
So I'm going to let you go online and look up something called Defense in Depth, and then we can go talk about this afterwards. Good talk. I like it. All right, so we're going to talk about some stuff
Some stuff.
and some more stuff. Great. All right, file concept. So the file, contiguous logical address space, it has types. Well, data and a program are really the two that it comes down to. AK, when we think of file, we just think of this contiguous address space or contiguous data that we want to edit. Usually it's either data or a program we want to run. Data can be numeric, character or binary. All right, so file structure. First off, we could have nothing in it, or no structure, I mean, which is just a sequence of bytes. Some simple record structures people use are lines or fixed length or maybe, variable length. I guess that's not too simple since your length is varying a lot. But you can use some type of formatting with like an XML document.
1 byte to define the length and then the variable length.
Well, yeah, but what if the variable length's more than 256?
And split it up into multiple variable lengths.
Is that simple?
Or whatever you're operating, 32-bit byte.
But then that would require you to know how large the file system can handle,
Yep,
which is not an
problem.
assumption you want to make when you're discussing the interface.
That is a problem.
It is indeed. How do we solve that problem?
We don't care what the operating system they use. We just read in 32 bits regardless.
That sounds like a accurate answer.
It does.
Going with the other answers in the class so far.
I'm glad I've taught you something in operating systems. We don't care. We ignore the problem. It's a common theme in OS. But hey, look, who decides, the operating system or the program that's reading the file? So,
Neither.
or neither. Okay, sure.
It's just a random series of bits.
Is it really random?
No.
Thank you. File attributes.
Not even in the random number generator.
The random number
It's
generator?
pseudo-random.
It's pseudo-random? Yeah, I guess that's true too. Or do you disagree, Matt?
I can make it pretty random.
You can make it pretty random. So how is something more random than something else? How do you gauge a
Well,
randomness?
you hook up like a little sensor to it and start shouting at it, throwing it around at the wall and stuff, and then take the sound and then seed it from that or something. Get
What if
something nice
somebody
and
gets a
random.
recording of that exact scenario and reproduces it exactly?
And a
It can
soundproof
reproduce
room.
the exact same answer, which is not random.
He's just saying that method could be replicated.
Yeah.
And therefore it's not random. But I was asking, that was not my question. My question
I said
was,
pretty random.
right, so you said pretty random, and my question was, how do you determine whether something is more random than another?
Hopefully not with factorials.
By the probability of replication.
Okay, probability of replication. All right. Well, that was a great sidetrack. So your file's going to have these attributes.
I just made this big word up.
It sounded great. I'll just take it and
You
run
should
with
cut this part so they don't hear that and they think it's a thing.
All right, file attributes. You know, the name, was it identifier, usually a tag to say where it is in the file system, some type of ID. Type, needed for systems that support different types. Are there systems out there that don't support different types?
Probably.
iPhones? Does the operating system have to distinguish between different types, like a character file, or a Word document, or HTML?
Probably helps.
Does it have to?
No.
No. Some OSs do. Linux does not care. It's just a file. Windows has some type data stored with it.
Uh-huh.
Location, where the file is, of course, located on the device.
I
Size.
thought that was the identifier.
Identity tag identifies it within the file system. So,
I think you just said it wrong.
no, I said it right. This helps find, okay, yeah, the identifier will help with the location, but the identifier is going to help you find the location. Location is also part of the attributes. You could have the ID map into something else that gives you the location, or you can store the location directly with the attributes as well. You're not going to uniquely identify it by its file location on the device. Ooh, why is that?
Because each device can store in a different place.
Store in a different place, and you may have two files that point to the same location. That'll happen as well. Welcome, Tyler.
Two different files?
Yeah. Two different files that are pointing to the same location. I put different in quotes for people who can't see me doing that online, because really you're pointing to the same file. Yes, they are essentially the same file, but you may have two different file attributes that point to the same file
Gotcha.
with different IDs. Yeah. Of course, the size, and then protection. Usually with reading, writing, or executing. Well, we got time, date, and user identification also for protection, although not necessarily required. And what we got? Information about files are kept in the directory structure, which is maintained on the disk. So this depends on your file system that's somehow handling where all this stuff is being stored. All right, Tyler, we had a discussion earlier, so we're going to ask you this question. How do you gauge the randomness of something? Oh, nice. Good answer. I like the short answers. File operations. All right, you want to create, read, write. Hopefully those first three are obvious. We have reposition within a file, move stuff around, delete it. Oh yeah, and then truncate it. Ooh, what's the difference between delete and truncate?
Delete deletes from point X to point Y. Truncate deletes everything from point X to the end of file.
Okay, close. Delete's going to get rid of the whole file altogether. Truncate just zeros it, makes it zero. I mean, delete's going to get rid of,
Zero.
makes the size zero. It has no data anymore.
So it's a blank file.
It's a blank file, so the file still exists.
Okay,
It's just been
truncate I used was different.
yeah.
So you just fill it with a bunch of zeros.
No, the file size is zero. It's been truncated. It's been, all the information has been removed. It's
So
an empty file now.
Deleted's still there.
Yeah, no, when you delete it, the file's gone. When you truncate it, the file's still there, it just contains nothing.
When would that ever be useful?
Yeah.
A lot of times you'll still need the file to exist for maybe someone else needs to dump something to it. Like maybe you're doing message passing through a file, producer consumer, so the consumer truncates the file by getting all the information and the producer can then fill it back up.
Okay.
So when you open, you want to search your whole directory structure to find the file, then close, move anything from memory onto the disk. Okay, sure. All right, several pieces of data are needed to manage open files. You need the file pointer, knowing where it goes, and a file pointer count, which is the number of times a file is open. Why would we want file pointer is hopefully intuitive because you need to point to where this thing is. But the count, why do we want to keep track of the count? Oh wow, we say it right there. Anyone want to read the slide for me? Know that? You
So
don't?
it doesn't write out to disk until the last file closes.
Sure, yeah. You know when to close all the memory for your file descriptor. Yeah. So disk location of file, cache of data, access information. Ooh. One important word's in there.
Cache.
Cache. Oh, okay. Disk location of the file, cache of data, access information. Right. So what it's saying is you really want to load in the file attributes and probably some extra information in memory, so you're not constantly reading from disk. So you're reading a lot of basically the file header information is a good way, what I like to call it. You also want to store your access rights. All right, file locking. Did you know you could lock the file?
Yeah.
We assumed.
We assumed you could. So there is mandatory, where access is denied depending on the locks held, and advisory, where the processor can find the status of the locks and then decide whether to deny access or not.
That sounds hard.
Which one's hard?
Advisory.
Advisory. It's hard for who?
Not the operating system.
The operating system? So then you're saying mandatory is easier for the OS?
Yeah.
Well, who's implementing the lock in a mandatory system?
The operating system.
Who's implementing the lock in the advisory?
Programmer?
The programmer of the program, right?
Yeah.
So which would be easier on the operating system?
Advisory.
Advisory.
No, because it has to figure out what to do.
No, the OS just says, yeah, there's a lock.
I
That's
like
it.
the OS.
There's a lock. That's all the OS says. In mandatory, it says, no, permission denied. There's a lock here held by blah, 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 and he has to keep track of the lock and everything. But on this one, the advisory says, yeah, someone opened the lock. They haven't closed it yet. Which one's implemented?
Advisory.
Trick question. That one is implemented, and so is mandatory. Which one do you think Windows does?
Mandatory. They like being difficult.
Yeah. What do you think Linux does?
Advisory.
Good guess. Yep. That's how it is. We are not looking at
Java
IO.
sucks.
One more time louder.
Java sucks.
All right, good. All right, file types. Some OSs like to identify things by extensions, aka Windows. So you might have an executable as an exe, com, bin, or none, object file, source code, etc., etc. Linux, on the other hand, doesn't care what the extension is at all. So you could
Has
have
to match.
has to match.
When you open the file, you still need the extension.
If you put an extension on it,
Yeah.
but you don't have to.
Right.
You could have a .pdf that's really an executable, and that's okay. Linux doesn't care. All right, so we have two different access methods. Sequential access, where you can read the next, write the next. You can reset back to 0. And was it no read after last write? So you can't rewrite the last byte. AKA, you're just sequentially reading and writing. And then direct access, where you can just basically read in, write to end, go to some position, read, and then rewrite when you want to. Which one do you think's desirable?
Direct access.
And which one do you think's difficult?
Direct.
Direct access.
Yeah, pretty much. Sequential is actually how a lot of it's done. You'll have your current position in the file. If you use fopen, fwrite, fread, this is what's essentially being implemented, although you are allowed to jump around the file, so in a way it's direct access, actually. But yeah, you're at some position, you can read and write this way, or you can rewind to the beginning. But the C version allows you to actually rewind to a certain location if you want to. You can also go forward a certain amount as well. Right, so reset, and then if you want to read the next byte, you read it, and then you increment your pointer, character pointer, I guess is what CP is here. It should be byte pointer. All right, are we good so far?
Yes.
Why would we want to have an index file and then the relative file? When would this occur? What is an index file? Love asking questions.
It looks like,
If you had a really big file.
Yeah, if you had a really big file, it might be good that you could search by last name, find the
looks like
index.
paging.
It does look like paging or
Caching.
caching. Huh. We just can't get around that word, can we?
No, you won't let us.
No, I won't. I won't. So yeah, it's a cache. Index file, you're caching it so you know where the location is. But usually, yeah, you'll do it by last name so you can find it and then move over. Although with an index file, the idea is that you've cached all the contents. So you're not just caching a small portion of it. And it's good if you have a very large file, right? Okay, directory structure.
Caching everything.
What?
Isn't that the same thing as?
No, because in a hardware cache, you can't cache the entire memory, right? You can only cache a small portion. So the index is just caching all the names to point to a location.
So you
it's-
said ideally they would have everything now.
In an
So
index
maybe
file, you would
Social
have
Security
everything.
and the age too, or just?
They would have everyone's last name.
Oh, okay.
Yeah, thank you. Everyone's last name. Yeah, they wouldn't have everything else, just everyone's last name. Okay, directory structure. One thing to keep in mind is a directory is actually just a file. It's a file that lists other files. In general, that's all a directory is. Here, you might have a bunch of directories, and here we're just pointing to, each one of them are pointing to a file, just to tell you that a certain file is inside of a directory. Since a directory is a file and a directory can point to other files, a directory can therefore point to other directories. Good so far? All right. So disks are usually divided into partitions, just to give it different sections. And those partitions can be RAID protected. We're going to talk about RAID in a later chapter, but for now, RAID is a cheap, I'll say relatively cheap way to improve performance and reliability by using multiple disks that act as one. Have y'all done RAID before? In any class?
Not in class.
Not in class, so no class has done RAID. All right, so we're going to talk about it here. Great. It's not that complicated. The problem is you have to memorize what the different levels mean, because the numbers don't actually correlate to something. You just have to know 0 means this, 1 means that. But we'll get to that. You can have them raw, or your partitions can be raw, aka not formatted, or of course formatted with the file system. I don't know why you would have it raw right now. It doesn't make much sense, so usually you have at least one file system. And some people like to call partitions mini disks or slices. That's just silly, so I'm going to use the word partitions. That's the entity containing file systems known as a volume. Sure. Each volume contains file systems as tracks. And hopefully we're going to get into basically this has to go with how tracks are laid out on your disk. And we'll go into a little bit more about that. But there's a division here with volume and tracks and general purpose. Let's see. There are general purpose file systems, and there's also special purpose, depending on what you want to do. For example, general purpose is usually what you're used to. The ext4 or NTFS is general purpose. Special purpose might be, for example, Linux has a swap partition, which is specifically used to head up your swapping of processes in and out of memory. Here's a great example. First partition has a directory with files, so does B, and so does C. Notice that a partition can span multiple disks, or a partition can only be a part of one disk. But the idea is that you're viewing it as one chunk. All right. What can you do to a directory? Well, if you're inside a directory, you want to be able to find a file that's in it. You give it a name, you want to be able to find its location. This isn't like a find or a locate command. This is, all right, I want this file named blah, 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 named hi.txt, where is it on the disk. The directory needs to be able to tell you where it is, or on the disk, or where that file pointer is. Directory, of course, you want to be able to create a file in a directory, delete a file, list everything, and then maybe rename it as well as traversing. So these are different operations you want on a directory, which again is just a special file. All right, naturally you want to organize it so it's efficient, the naming makes sense, and that you can do grouping by properties, possibly all Java programs, all games, all other binary files as well. Okay, so we're going to go through real quickly the evolution of directories. We don't do single level directories, at least not anymore, but we're going to start here. Single level directories is that there's only exactly one level directories. They each point to a group of files, and every user on the system can see every directory. So the problem here is if you have a user that they both want to have their own file that has the same file name, is that going to cause a problem?
Not if they put it in different directories.
They both want to have it in the same directory. Nice.
Yeah, that sounds like a problem.
Sounds like a problem. Also, if they have it on different directories, how many directories are you going to see in your when you first load this thing up?
However many directories there are.
Which is a lot, and not exactly helpful. All right, so maybe this isn't the most efficient solution. You could do two level, where every user has their own set of directories, right? But what if user 1 wants to look at user 2 files, or they want to share?
Go to their computer.
You go to their computer, right?
Email me this.
Email me this. Yeah, it may not be. Why don't you email me this, man? It used to be a .mail directory, right? So that's where it would be. All right, yeah, but it does solve the naming issue because now everyone can have the same name with their own file. But
User 1 is the share user. Everybody can access user 1.
Okay, so that's a master share. But what if you only want some group of people to share and other groups to share?
Then you have more users.
Man, you're just making us complicated. All right, tree structure. This is getting closer to what we're used to. You might have, root, 3 directories, and then each directory can also have a directory inside of it. The point here is now maybe you'll have a home directory with all the users, and then in there they would have their different contents. That way you would have a way to backtrack out to everyone. And also this solves organization problems because you don't have one long flat naming scheme. So tree structure sounds a lot better. Although which of the 3 is hard to implement?
The tree.
The tree. But wait, there's more. Okay, not yet. Tree structure, you want to be able to search it efficiently. You want to be able to group them and be able to find the current working directory as well. All right, fine. So you have absolute or relative path. Do we know the difference between this? Did we talk about this? Yeah, what's the difference?
I don't know if we talked about it.
So
Absolute path goes from the root of the file system.
right.
So you have to start at root and tell it exactly which file path to go through. Whereas relative, it takes your current working directory and works from there.
Let me give you an example, just to make sure this is clear. Because I know Matt has no idea what I'm talking about.
No, man. It's the same with the Mac.
It's the same with the
Very
Mac.
That was an example of relative.
All right, so relative, if I wanted to load up something in lab 2, I would go up 1 directory, so I'd be up here, and then over to lab 2, and I could load it up. But if I want to do absolute, I'd go /home, quest, CSU, courses, CSCI, 431, lab 02, lab 02. And this is the absolute path. The reason for this is no matter where I am in the file system, if I go right here, if I use the absolute path, it's going to come up. If I try and use the relative path, since it's relative to my location, it's not going to happen.
Lots of settings will occur.
Yeah, lots of settings will occur.
No such file or directory multiple times.
Well, they just want to make sure you understood what was happening. Any questions?
You tried to open up like 20 files.
How do you know I didn't? All right. Yeah, you can do this for moving, making, etc., etc. Hey, look, deleting the mail directory used to be able to delete everyone's mail. I bet that was fun. All right, acyclic graph directories. Oh boy, taking this a step further. So you might have under a dictionary count and under spelling count point to the same file. Is this allowed by most file systems?
Yeah.
Yep. Yeah, might point to the same one. Is this acyclic?
Shortcuts.
Right, shortcuts. There you go. Shortcuts, or what we like to call links. And you might have soft links or hard links. But yeah, this is fine. You might have a shortcut somewhere pointing to the same file. No problem there. It's called acyclic because there's no cycle here. It's not like you have one link going here, goes to another link, and then comes back around. So it's acyclic means that cycle does not occur in this graph. So this is what going back where you might have two different file headers or attributes, one here and one here, but they're both pointing to the same location. Different IDs because they are unique descriptors, but they're pointing to the same file. So what happens if a dictionary deletes, well, not list, but count?
Wait, are those two separate lists, or are they saying it's the same
I think
one?
they were talking list because there's still
I
a
think-
file that no longer has a way to access it.
Well, if you delete list, you're deleting what's with it. Isn't that what they're talking about? Yeah, no, I'm pretty sure that they meant count.
Okay.
If you delete this count over here, that count still exists, but it's pointing to
Nothing.
nothing. So you have a little dangling pointer issue here. So you can try and use back pointers so we can delete all the pointers. You can use daisy chaining, entry and hold count solution that it doesn't get deleted until you actually,
Ignore it.
or right. Or you can be a real operating system and
Ignore it.
ignore it.
Doesn't happen.
It doesn't happen. The way we
Which I
really
think is
solve
what is
this?
implemented because I think I've come across that problem.
Oh yeah, you will. Hopefully you found the pattern. If something's too hard, we just don't do it.
That's like
If
my
the
life motto.
slides offer multiple
Maybe you should be an
solutions-
operating systems programmer then.
Be great. Be the best operating system ever.
If the slides offer multiple solutions, the real solution is we don't do anything.
Yeah. Pages and pages. What's done?
This is
Nothing.
what you could do.
We're not doing it.
None of these are.
We're not doing it. Nah. That's too. Yeah. All right. So this is back when we're talking actual links. What I like to call hard link, but what they're calling now is actually have a link which points to the file, or what's more of a soft link. So you resolve the link, you follow the pointer to the file. Let's go do a quick example. Let's see. Class code. Okay, links. There's no way I'm going to be able to commit this since we're going to be deleting. All right, we'll go open up hello.txt. And I'll say hi. All right, so I can go ahead and cat that real quick. It says hi, I'm going to clear it. So if I make a hard link to a.txt, what is it called? Hello.txt, and I'll call it, what should I call it? Bye.
Corgi.
Corgi? How do you spell Corgi?
Corgi.
You want to make it TXT or just Corgi? We'll just make it Corgi.
Dot Corgi.
.com?
Yeah.
Alright. LSSLH. Hey, look, we have two files. If I cat corgi.corgi.com, it says hi. If I delete hello, and then I do an ls, Corgi's still there. If I cat it, what is going to happen?
Sadness.
Hi. There's a hard link. The file does not get deleted there in a hard link because the link count was not 0. On the other hand, if I do ln-sf, we'll do to Corgi, making a soft link and not a hard link. And what do you want to call this one?
I'm out of ideas.
of ideas. Got it. Here it's a little different. Now we have I'm out of ideas pointing to Corgi. So what happens if I delete Corgi?
Deletes I'm out of ideas.
Nope,
Delete
still there.
not Sadness. Oh,
But
it looks
it's
like
pointing.
sadness.
It's still there, but if I try and cat I'm out of ideas, no such file or directory, because it was actually deleted. So a hard link in Linux is going to do the whole link count thing, but a soft link is just going to be a pointer.
Now we're pointing to nothing.
Now let's take this to the next level. So we still have hello.txt. Oh, actually, we have I'm out of ideas. What if I make a soft link from corgi.corgi.com to I'm out of ideas? Oh, I'm sorry, I did that backwards. A soft link that goes to I'm out of ideas, and we'll call it corgi.corgi.com. Is it going to accept it?
Loop.
It took it. Let's do an ls-lh. Yeah, they're just pointers. What if I try and cat I'm out of ideas?
Sadness.
Infinite loop.
Too many levels of symbolic links.
Oh, not infinite. Figured that
So
out.
the LS actually tried to point the way down and go through the tree, and when it couldn't get to anything, it said, I'm done.
How many levels does it take for that? That took a while.
Yeah, they, yeah. Oh, that's a great question. Let's do a time on that. That didn't take that long. I don't know how many levels Linux allows. It's
When
probably,
you first did that, they just cached that. Because that didn't take any time at all. But when you first did it, I mean, it took a second. You cached it.
okay, it took a little longer, but not much. I don't think that happened. I think you're seeing things. We have video recording, so we can go back and see.
Yes,
At the end of club.
because, the other one wasn't
No.
cached at all.
All right, so that's interesting. Is there any way to do this with a hard link?
Let's have a point to a file. And no, because
I can't think of a way to do this with a hard link, because a hard link is the actual file. It's not a pointer. It is a strict alias. So,
well, what if
because you have to create the file before you can create a hard link. So the file has
create
to.
a file.
Okay, we'll create a file. Okay. Created. You want me to create a hard link
Hard
to?
link to hello.txt.
Okay.
Create a hard link to that hard link.
Okay.
Change the original hard link to link to the other link.
No, you can't do that.
Can't change the link.
No.
It's worth a shot.
I wonder what Git would do if I tried to add all these things. Ooh,
Die.
it would die. All right, well that was fun. And next we have general graph directory. Book points to AVI, AVI points back to book, which then points to AVI, which points back to book, which points to AVI. And yeah, you see the issue here. How do we guarantee no cycles? We can allow only links to files and not subdirectories. So we just, we could say no links. Nah, we could do garbage collection where we try and figure it out in the background. That takes way too much time. Every time a new link is added, use a cycle detection algorithm to determine whether it's okay. Why would we do that? It's really sad here because they did put bullet point 4, which was ignore the problem.
Well, that doesn't guarantee no cycles, though. That wouldn't satisfy.
Oh, I'm sorry. How do we guarantee no cycles? Right. So we don't guarantee, huh?
It doesn't happen.
It doesn't. We pretend it doesn't happen. Right. That's our guarantee. Always a solid.
Just let it cycle out.
Called.
Whatever.
Who cares? Whatever. The programmer knows what he's doing, right? Maybe. Okay. We're going to go back to something called mounting. A file system must be mounted before it can be accessed. This is just helping you understand where your file system is in your directory structure. So for example, you might have Sue's mounted to this partition, Jane's mounted to these, and inside of Jane's partition, they may have other mountings to other file systems. What is it saying here? Existing and unmounted partition. Oh, it's saying that it's not, but it's not mounted here. I don't know what that they're trying to say up here. Forget
He
that.
is unmounted.
Yeah. B is unmounted? Looks mounted to me. Alright, mount point. I just said this. Where's
Oh,
it?
go back. They didn't have the slash on the B. See, an A had
Oh.
a slash in the front.
Oh, good catch. Nice.
That tricky little slash.
It really is. Mount point. Slash users slash Sue, that's where the file system is there. Also, usually your slash mount point is the beginning of at least one file system, or it has to be. Otherwise, it's going to be an interesting experience. Okay, file sharing. We like to share files. Do you all like to share files?
Nope.
Sure do.
Sure do.
That's plagiarism.
It's whoa. How could that be plagiarism? You might. What if you're sharing something that's okay to share?
They must cite my work.
Let's cite your work. Well, just attach a license to it, right?
I don't share. I wasn't taught that in kindergarten.
You were taught that in kindergarten.
Was fine.
You know what? They don't actually teach that in kindergarten anymore. It makes me sad. I went to the whole time, and all they cared about was whether my daughter could learn to count and identify letters and
I
read.
know in Japan that they spend like 2 years on just, what is it, like common decency type stuff.
Oh, that would be beautiful.
No education, or no,
Well, yeah. If you're not able to be a decent human being, how are you going to
yeah,
learn?
it's literally things like you have to share, you have to say please, you have to say thank. Formal education system teaches them that.
That's beautiful.
We should adopt that for our kindergarten.
And first grade.
And first grade, sure.
I think we need to get it for the teenage years because that's when it gets bad.
I think they.
But if they're taught that from
Or-
the start,
You see, I think the point is, teenager. There's only so much you can do there, right? The point is, you get them at least get that knowledge in their head before they become
Foundation
teenagers,
phase.
so they know what they're supposed to be doing. I think the problem right now is a lot of them just don't even know how you're supposed to
stop
treat one
creating
another.
sociopaths, in other words, that don't know right from wrong.
Sure.
But they know how to write in cursive.
No,
It's not
they're doing
teaching
away
that.
with cursive.
Yeah. No.
No, they're not
Kids
going
are doing it right now.
to. My school is not going to teach cursive.
Well,
They
that's
said-
because you pay extra money for them not to learn cursive.
No, I'm not paying any money.
I thought they were going. Oh, that's right.
It's a
You're
charter school,
Yeah,
so
okay.
it's still publicly funded.
Okay.
Matt, you want to have any say on this? You know, we were doing some good public school bashing.
Abolish all handwriting.
All handwriting, type everything. It's the wave of the
I'm
future.
okay. I'm okay with getting rid of cursive though. I think the only thing that they need to learn how to write in cursive is their name.
I was about to say.
No, because you are allowed to sign your name in print.
Oh, are you now?
You're telling me my elementary school teacher lied to me?
Say it again. Here
Didn't
soon.
your elementary school tell you that there's no number before 0?
Probably.
Here soon, all signatures are going to be electronic pens, so
Oh yeah. Attached to bitcoins, right?
possibly. I still have no clue what those are.
It's cryptocurrency, man.
Those signatures are better than electronic ones because I just put smiley faces.
I do that too.
They're like Walmart, they make the sign. Just,
Sometimes the cashier catches it and laughs, and we just move on, right? Yeah. All right. Anything else about sharing? Do you have a strong opinion about sharing?
I like sharing.
Okay, good.
I am the one nice guy in the classroom.
You are?
No, I am.
Oh.
I need lunch money.
We.
Can you share?
I don't eat lunch. I just drink energy drinks.
I need new energy drinks.
You know what's
I'll
coming.
have to hit up my mini fridge.
Nice. See, nice.
Don't have one of them either. Can I share?
Sharing, not communism.
Oh.
I'm only asking for you to share, where I may not give it back.
Borrowing with, oh, anyways. All right, so usually you want at least some level of protection so people don't accidentally share everything, because then that would be,
Communism.
right, all right, good. On distributed systems, files, of course, may be shared over a network. So now we need a file system that works over the network. Guess what it was called?
Network file system,
Man.
NFS.
Oh man, that was amazing. At least that was what the first one was called. All right.
Now it's network file transient system.
No, that is
Transport.
that's something else. NTFS is not a network file system. Yeah. All right. Usually, how do we do this? Well, you want to have an ID to identify users, and pretty much all operating systems, in addition to IDs to identify users, they have something called groups. What would be the point of having groups?
A lot of people with the same privilege.
Same privileges.
So
There's
the communists can be communists, Democrats can be Democrats, and they don't
Capitalists.
talk to one another.
Yeah.
capitalists can be capitalists.
Yeah, and they don't talk to one another.
All right. So we can silo everyone, right?
Huh?
And we can silo everyone.
Sure.
Yes.
So they don't talk to each other. Another feature I learned about the military. Interesting feature. All right, remote file systems. Wait, what's the difference between distributed and remote? Oh, it uses the World Wide Web.
Whoa.
Wow, really? All right. Wow. Usually it's a client server.
Seamlessly using distributed.
Yeah.
Seamless.
So
All
there's
right.
3 different types.
You can do it manually with FTP. That's file transfer protocol. You can do that in applied networking, right? FTPs? Yes. You can do the distributed file system, or you can use the World Wide Web. Now, I don't know exactly understand what they mean by number 3. Maybe just going to web pages,
Google Drive.
Google Drive. Oh, so that's a GFS? All right. Usually there's a client-server model going on here. Obviously, a server serves multiple clients. Client, user on client identification is insecure, of course, or complicated. In other words, the server does not trust the client, which is a very good thing to do. Never trust your clients. They usually don't know what they're talking about. So the server has to do the identification. NFS is a standard, I'll say, Unix client server file sharing protocol. I have not met many people that still use NFS anymore, but I guess it's still out there.
Now
They use their implementation of CIFS, of
which is
Windows.
called.
CIFS.
Okay.
Right. They call it. They just use Windows protocol and wrote their own implementation, which, by the way, has better performance on Linux. But that's beside the point.
The one thing.
What?
The one thing.
The one thing? You think nothing else is better on Linux? I see how it is. The performance of CIFS on a Linux server is actually better than if you were using a Windows server.
Oh, well, I thought they were using the Windows protocol because it was better than NFS. So the one thing Windows did better.
I would not agree with that. They use CI. Most people use CIFS. That way, you can just plug your Windows box into it.
Because most people use Windows.
Right. In an
They
enterprise
don't have
environment.
marketing interns.
Yeah. So any standard call is then translated into a remote call. See, and then you have distributed information systems. These are something different, such as LDAP, DNS, NIS, Active Directory, etc., etc. All right. Do they talk about LDAP? They don't?
Wow.
All right, we're going to stop for a moment.